of embedded systems Monday from 8 a.m. to 10.
Okay, sir.
This will cover both hardware and software, that is coding. Also the interface, whatever I have taught. The portion which will come will be assembly language programming. Then interrupts, external interrupts. Then hardware interface. Covering this, so duration will be 2 hours. Marks. So Monday, that is 21st. 2022, 8 a.m. to 10 a.m. online. You can cut and paste this notice. This will be your exam, so it will be open book exam. You can say it is open book. So only thing we'll look is that you should not copy from each other, because we have 7 teachers. We can figure it out, and if copy is found, then both will get less marks. And I will not be evaluated till you justify why they are matching. Okay, so there should not be any copy. Handwriting, everything should be handwritten and uploaded. Okay. Are we all seeing clear?
Yes, sir.
Okay.
Sir, also a small doubt. Will it include design questions as well?
Design questions based on hardware. Hardware means analog, whatever you know. For example, based on operation amplifiers, counter, flip flops, etc. Like I have given a problem yesterday that you have only 2 interrupts. Make a circuit so that it will accept 8 interrupts. So anybody who tried it, can you raise your hand? Otherwise, I will discuss it. Like yesterday's question is what? In the yesterday's question, if you look at your AVR, there are 2 interrupts, int 0 and int 1, right? So external interrupt. So there are 2 interrupts here, as you can see, int 0 and int 1. So if you look at the pin configuration, so this will be in pin number. If you go to page number 3, you'll find they are at the pin number PD3, and there is another pin for int 0. Which pin is this? Which pin is this? PD3 is one pin. The other pin is which one? For int 0. Int 1 and int 0. Patient. There are two external interrupts. One is that is PD2, 32 and 1. So if you look at these two pins, so these are the pins where you can accept external interrupts. So forget about the pin change interrupts right now. So these are the pins. If you can see, these are the pin, this pin. So this is INT0 and INT1. Don't worry about the pin change interrupt right now. We'll not enable it. So you focus on these two. So this is included in your syllabus. So these external interrupts have some associated registers also. So if you look at that, so the associated register, so the vector table of INT0 is where? Asta, where is the vector for INT0? Asta Bhattiwara. Hello, Asta, are you there or not? अरे कहाँ है Asta Bhattiwara? Asta Bhattiwara, are you there? Please remove her. Please remove Asta Bhattiwara. Honestly, wastage of time. Okay. Amritaksha Purukayastha, please tell. Purukayastha.
Yes, sir.
Please tell where is the vector for INT0? Where is it located? When you interrupt INT0, from which location it will start working? Vector table. What is the address? Which location? Which location? Please go to page number 4950. Go to page number 49. Hello? Purkayastha, please tell me what is the vector? Which address?
Sir, which table am I supposed to refer?
अरे काल तुम नहीं था क्या क्लास में?
Yeah, I was there.
So if there is an interrupt, what happens? If there is an interrupt, what happens? If you press INT0, if this is enabled, then what is the thing which happens? क्या होता है बोलिए? Are you there yesterday? Attentive क्यों नहीं रहते क्लास में भाई? वो ऑनलाइन क्लास में कैसे मैं मैनेज करूं? I cannot manage online class otherwise. You guys, if you don't cooperate, so nothing is possible for me. You will not learn because you are unfortunate that your physical class. So you will pass from IIT but no knowledge. You got my point? So that will be your fault. We are not responsible for that. If you unless Purkayastha, you have to tell me what happens when you have interrupt. I will take it very seriously otherwise. You tell me, I will get back to you in 5 minutes. You tell me, okay? You explain what happens when you have an interrupt. Mohit, please tell. Mohit. Hello, Mohit, are you there?
Yes, sir.
Please tell me what happens when there is an interrupt. What happens?
Sir, I was not there in the class.
You are not there.
Okay.
Unfortunate, actually. You guys are. See what happens. You know, this pandemic is not good for you, but you are also destroying itself. अरे हम लोग का क्या है? हम तो ऐसे ही बोल के चले जाएंगे. प्रोफेसर का क्या जाता है बोलो तो? If you don't learn, एक ही तो कोर्स है जिसमें तुम मैक्सिमम चीज देख सकते हो. ठीक है. मानव नितिन कपडिस, तुम तो थे क्लास में. हाय कपडिस. हाँ. इंटरप्ट होने से क्या होता है एक बार खाली बता दो. When there is an interrupt, what happens? In this particular case, what happens?
So this particular pin will be set to 1, right? When
Okay,
interrupt
yes,
happens.
yes. So if this is externally set to 1, then what happens? What does the processor do after that?
Does it stop the current execution of the command?
Command.
So the program
Wait,
counter then I
talking
think
like a
enters a
layman.
different
You are-
subroutine.
Huh?
The program counter enters a separate subroutine.
Who is speaking? Please raise your hand.
Amrita.
No, you don't have to speak because he is now. It is his
Okay.
turn. Whoever is speaking, please raise your hand. Who can answer? Please raise your hand. Shubham Kumar. The only guy, one guy can answer. Out of the whole lot, only one person. I have become a failure to teach you. Okay, Devendra, yeah. गुरु कहता अभी सीख लिया. ठीक है, शुभम बता सबको.
Sir, once the interrupt flag is set, then the program will jump to that INT0. If INT0 is set, then INT0 vector location.
Where is that location? It is
002.
Okay. So.
And then that interrupt and that
Yes.
program, whatever it is written there, that will get executed. And then
Right. Yeah, okay. I got your point. So before that, it will check whether it is enabled or not. So where is the interrupt, global interrupt enable flag? Can anybody answer this? Ajay Mishra, can you answer? Shubham को एक star दे दो.
Yes, sir. Status register.
Give a star to Shubham.
Yes, sir.
अच्छा, अजय मिश्रा पता हो तो global interrupt enable flag कहाँ है?
Status register bit 7.
Status register, excellent. So give a star to Ajay also. So these two guys are actually impressing me a lot. Okay. So Purushkayastha, अभी तुम्हारा बारी है. So what are the external interrupts? If you look at the interrupts 1 to 26, I think there are 26 interrupts. If you look at here, so which one of them are external interrupts? Purushkayastha, ये answer दो दोगे तो I'll be happy. Who can answer this? Which are the external interrupts here? External, that means you can use it by other devices. Himabindu. Okay, Himabindu, tell me which are the external interrupts?
Int 0 and int 1.
Also PC int 0, PC int 1,
Yes,
PC int 2. All these are external interrupts. We are not talking about the pin change interrupt. In pin change interrupts, how many pins you can use?
4 each.
You can use 24 pins.
Okay.
Any changes in that will interrupt the processor. Okay. All right. So you guys look at this 49 page of this manual. So let me discuss about few things about interrupts. So the external interrupts are associated with certain flags. So more than that flag, there is a microcontroller called MCU control register. Okay, MCU CR. उसको कहते हैं MCU CR. So this MCU CR, this is called microcontroller, or you can send MCU microcontroller unit control register. You can write like that. This is page number 52, okay, of your that Atmega 32P data sheet. Okay, do you have the data sheet? I have already given you, or it is there if you are not. Data sheet is there or not? So this is the location of MCU CR 0x35 and just 55. These are the locations. Please bear with me. MCU CR. So MCU CR, there are 1, 2, 3, 4, 5 bits. Out of the 5 bits, you can write in 3 bits, that is 4th bit, 1st bit and 0th bit. Other bits like by 5 and 6 are only read. They are used for booting. Okay. So just a minute. So bit 1, if you look at it, bit 1 is called IV select. Bit 1. This bit is called interrupt vector select. This is interrupt vector select, IV select. IVC is interrupt vector change enable. IVC interrupt vector. So you can change these two. By changing these two, you can change the vector memory. Whether you want to go to the flash memory or the boot section of the flash memory. Remember this. We'll talk about bootloader support later on. So right now you don't worry about it. So this IVSCL and IVC together tells you where to put your vectors. But generally in the Atmega 328P, it is all in the beginning, flash location. You have no option. So that is what is this. So by changing this MCU CR, you can change the vector address, right? So just remember that. All other bits are associated with the bootloader. Don't worry about these 3 bits. We'll talk about it later. With the external interrupts, there are few things which are associated. So there are 3 different types of external interrupts. So what are they? So one is this. Please be attentive. One is this INT 0, then INT 1, then this PC int. So there are pins for PC interrupt, pin change interrupt. It's called pin change. There are 23 pins. 23 pins. You can see there. So when these PCInt230 pins are configured as outputs, those ports are configured outputs. If you receive any signal, that will act like a interrupt. Okay. So there are 3 groups. It is divided into 3 groups. So for example, PC23 to PC16. This corresponds to PCY1, PC interrupt 1. Similarly, PC14 to PC8. So they correspond to, sorry, this is PCI 1. This is PCI 2. Sorry about it. Then PC7 to PC0. They correspond to PCI 0. So remember this. So this I have already discussed yesterday, that where is this PC16 to this, you can just, if you look at this one, you can find out. If you look at this, so these are the PCI. You can see PC into 1, 0, 11, 14, 16, 17, 18. So these groups are there. They are located in port C and port D. Then they are located in port B. Port C, port D, port B. So these 3 ports, if when they are configured as output, so that can accept interrupt, external interrupts. Remember this. So this is how you enable this. So these are the 3 groups of internal, external interrupts. But now we'll focus on this interrupt 0 and interrupt 1. We'll not focus on this. So these are the 2 interrupts. Now yesterday I gave you one hardware design where, so you are supposed to so there are 2 interrupt pins like INT 0 and this is INT 1. And let's say there are 2 devices which are trying to interrupt, device 1 and device 2. So this is sending one signal. Sorry, 4 devices. I said 4 devices, D3, D4. So how to connect them? So first of all, you have to give some interrupts this one. So that means you put an OR gate here, then another OR gate here. Then whenever they are interrupting, you can connect them to port. So there should be some flag. 1, 2, 3, 4. for D1, D2, D3, D4. So whenever you are receiving an interrupt, this is your MCU. On this, so you check these two flags, which one is enabled. Then you serve that interrupt service subroutine in a priority manner. So this is a very simple design. Ashish, could you get it? Ashish, Mr. Ashish. Ashish, you are never there. Whenever I am calling you, you are absent. This is very serious thing. Ashish. Hello, Ashish. You are never there. I don't know what happens to you. Ashish, are you there? Okay, Asta Bhatwara. Asta Bhatwara. Hello, Asta. Again, what happened to you? Yes, are you there? Last time I called you, you are not there. Are you there, Asta?
Hello, sir.
Last time I called you, you were absent. Where did you go? I told you if you are joining, then be attentive. Otherwise, you need not join. I am not taking attendance. So why are you joining and remaining silent or going somewhere?
Hello.
Okay, you tell me. You tell me what is this I am explaining right now. I don't know actually. What can you do? Last batch बहुत अच्छे मतलब I could actually explain something to them. In your batch only few people are sincere. What happened to you? Okay, Asta, can you figure out this? What I am explaining? You are not attentive anyway. Meena, Anshul Kumar, Meena, you tell
Hello,
me.
sir.
Yes.
Hello.
Yes, tell me. I'm listening to you. Anshul, Meena. Hello, Anshul Kumar, Meena. Meena, Anshul Kumar. अंशुल कुमार मीना कहाँ है? उसको रिकॉर्ड करो, नोट करो. Pooja, this guy also is cheating.
Okay,
He's
sir.
not- I'm very sorry about it. Why people are okay. Devendra Praveen.
Yes, sir.
Yes. What I'm trying to explain, can you just tell me?
Sir, means if there are 4 devices and if we have only 2 interrupt pins, so we are using OR gate for 2 of them.
Yes.
So if any of them is high, then OR output will be high and so interrupt will be high.
So suppose he receives an interrupt here. How will you know which has interrupt? Suppose he receives an interrupt in this pin, then he goes to the ISR. Then what? Then how will you know which one has interrupted?
Sir, we need to use some mux-like device for that, I guess.
No, you have to connect these also to the flag, some ports. 4 flags. So this will enable 4 flags. You read these flags through some ports. There is a port C, port B, port D. So you can use a port to read these 5 flags. Whichever
Okay.
flag is enabled, that interrupt service subroutine you have to. So this is called polling. You can figure out from that which one is. So you please do that.
Yeah.
So all the interrupts. So each of the external interrupts.
Sir, how will we connect them to the flags?
So there are ports in the so that the Atmega has certain ports like port B, port C, port A like this. So you can connect 4 points of the port to the devices. So this will set these pins. Suppose device 1 is here, device 2 is here. They are also connected to interrupt through OR gate. So whenever then INT0, it will check this port. Whichever is enabled, it will serve that ISS. You got it? Are you getting it?
Yes.
So each of the external interrupt is associated with Forget about PC into pin change interrupt right now. Let's only focus on the interrupt. So there is an EICRA. This is a register which is used for control. This is called external interrupt control register A. This is called external register, external interrupt control register A. Whenever I'm asking questions, please switch on your video and answer. So this is an 8-bit register. As you can see the structure right here. So the location in the memory map is the address of this particular location is 0x69. That means hexadecimal number 69 where you can write. That is where this EICRA is placed. Okay. So this has got 4 bits which are read write. One of the other things are ignored. These 4 are ignored. They are all 0, 0, 0. So initially they are all 0. So these are called interrupt INT0 sense, interrupt sense control. It is called bit 1, bit 0. Okay. So this is sense control means whether, if you look at sense means whether INT0, this is for INT0, this is for INT1. These two are for INT1. So by different labels 0, 0, you can say that this interrupt 1 or interrupt 0 is called low level fired. That means 0, 0 means whenever the interrupt becomes low, it will be enabled. Okay, so if it is 0, 1, any change, suppose this is 0, 1, any change in the interrupt 0 will generate an interrupt. If it is 1, 0, it is falling edge. If it is 1, 1, it is rising edge. So there is no trigger when it is high. Only when it is low or any change that will be triggered. So if the table shows this for the interrupt 1 and interrupt 0. This is the table for interrupt 1, you can see. This is for interrupt 1, similar to the table for interrupt 0. This table says that if this IS1, this is 0, 0, that means interrupt 1 will generate an interrupt only when it is low. If it is 0, 1, any logical change in that line will generate an interrupt. If it is 1, 0, falling edge, if it is 1, 1, rising edge. Remember how the interrupt is. So this is called interrupt sense control. All right. So this is for interrupt 1. Similarly, that is for interrupt 0. This is for interrupt 0. This is for interrupt. Is it clear to you? Asta Bhatwara, now is it clear to you? Whatever I said. Asta Bhatwara, are you there?
Yes, sir.
Is it clear?
Yes,
Whatever?
sir.
So what do you mean by this? What are these 2 bits? ISC 00
Yes,
and ISC 01. You please switch on your video. When I'm asking question, you have to switch on your video and answer. Switch on your video. In a class, I have every right to see you. Is it not?
Hello, sir.
Please switch on your video and answer this.
Yes, sir, I have.
Okay, you tell me. So what do you understand by this sense control? So ISC 00, ISC 01. Please be attentive in the class, otherwise I cannot help you much.
Like when both 0 and 1 are high, like when int 0 will be high. Hello, sir.
INT0 is an input to the microcontroller, it is output. This int 0 pin.
Sir, can you just repeat?
This int 0, there is an interrupt pin in the micro. Int 0. Okay. This is an input to the MCU or the microcontroller unit, or it is an output?
Too.
It is input. Okay. So now what does these two labels tell? What does it do? If INT0 is enabled, what happens to the MCU? You please find out. Yesterday I took the class. You please listen to the record. Recording is already there. So how many times you, if you listen to all the recordings of the class, it will be hours together. Better attend to the class. Okay, so how it will be enabling? INT 0, will it be enabled when it is high?
Yes, sir.
Yes. I don't think you have understood anything. Sai Narayan, are you there? Sai Narayan?
Yes, sir.
You can answer now.
Sir, this ISC is interrupt sense control, and that will determine when that interrupt will generate an interrupt request. So if ISC 11 and 10 are 00, then the low level of int1 will generate an interrupt request. So we can control when int1 generates an interrupt.
Okay, I got it. So fine, thank you very much. So that means high level it is not enabled. Either there is a change or it is 00. Anyway, thank you very much. So these are the two external interrupt register, control register A. Then there is one more control register. That is called interrupt mask register, which will disable and enable the interrupts. It is called interrupt mask register. Okay. So just like yesterday, so this is called interrupt mask register. Please look at this interrupt mask register. Page number 55, you can say 55, yes, page number 55. So this is called interrupt mask register. External interrupt 7. So this is called interrupt mask register. You can see. So mask means you can disable or enable the interrupts. There are 2 bits only. By writing, other bits are not used. They are reserved bits. They are all 0. So if you make INT1 bit 1, then interrupt and also so it will be enabled. If it is INT0 is INT1 is 0, then it is disabled. Okay. So this mask register can disable or enable the interrupts. So what is the other bit which are also which is also required to be? So only this one will control the interrupt, or there is one more bit which will also control the interrupts. Another place there is something else. Pankaj Kumar Meena, are you there? Hey Pankaj Meena. Pankaj Meena. भैया इसको हटाओ यहाँ से. मेरे क्लास में इस तरह का लोग नहीं चाहिए. उसको P ग्रेड दे दो. नहीं बोलो पंकज मीना, are you there? पंकज मीना, are you there? ठीक है. हर्षल लक्ष्मण.
Yes, sir.
Yes, sir. Okay. So tell me, these are the 2 bits in the interrupt external interrupt mask register whose address. What is this, by the way? What is this hexadecimal number written?
Sir, it is address of register.
Yes, address of this register. While reading, you read from this address. While writing, you write from this address. Okay. So both are external interrupt mask register. Okay. So these 2 bits will enable or disable these 2 external interrupt. Any other bit is there which is also required to enable it?
Sir, ISC registers.
ISC where?
In the PICRA.
That is different. This is Atmega 3223, the one which you are working on. These are where actually you need to. That was an external interrupt. So this one will enable. Is there any other bit which has to be enabled to make this interrupt enabled?
Sir, I bit in the status register.
Very good. Thank you. Give him a star. So the status register has also a bit which is called global interrupt enable. Unless you enable it, these interrupts will not be enabled. Remember this. All right. So then there is a third register. It is called EIFR, External Interrupt Flag Register. EIFR, External Interrupt Flag Register. Let me also bring it out. These registers has to be programmed. This register is basically these are flags. Flags means whenever there is an interrupt, this will be enabled. This is a flag register. You can see. So, for example, what is INT? This INT bit 0. When a age or logic change INT 0 pin triggers an interrupt, this is set. So depending upon whether this is enabled or not by EI mask and starter register, it will go to that subroutine. So the flag will be cleared after the subroutine is executed. All right. Is it clear to you? So these are just giving the flags whether the interrupt has occurred or not. Right? So these are the three interrupts which are treated as external interrupts. Okay. So now I shall tell you about certain coding examples. Certain examples how I'll write a question. You can Pooja can also put it as a homework. So I'll write a question which will be similar to your mid-sem practice. I am not giving you assignment, assembly language assignment now. I'll give it after the mid-sem because you have to prepare for mid-sem. So for example, I'll write like this. This is the question. Example question. Let me write example question. So it is required to sample a voice signal at using a 16-bit. It is basically a recorder you want to design. 16-bit A to D converter. Okay. 16-bit ADC. And generate it back after cleaning the spike noises. By an appropriate D to A converter, DAC. So the 16-bit converter will be given to you, the DA converter also, maybe 12-bit or 16-bit, whatever, will be given to you. So your job is the overall architecture is like this. This is your MCU. So this is your ADC, which is 16-bit. So this is your 16-bit ADC. So then this is your 16-bit DAC. This is your ADC. This is your DAC. So this is somebody speaking. So you have to design the pre-amplifier circuit here. Here also you have to send it to a speaker. Then you have to clean it. Clean the spike. Spike noise can be cleaned by simple median filters. Remember. So write a code. Draw the circuit diagram. Write a code. Okay, to achieve this. Are you getting the question? Any answer question? Are you getting this question?
So the ADC and DAC are external.
External ADC and DAC. This will be specified. Which ADC you will use? I can tell you. One minute. I can give you some ADC. I will tell you ADC specification. I can give you. Okay. So ADC specification I will give you. Don't worry. 16-bit ADC. Let's say there is a 16-bit ADC and 16-bit DAC. I'll give you the specification of this ADC.
So, sir, in microcontroller, do we need to perform that median filter?
Median filter. You have to do the median. For example, this one is 1. This is a 16-bit ADC. This is a 16-bit, as you can see. This is ADC chip. Suppose I give you this chip. ADS 11115 16-bit ULC ADC, 4-channel gain amplifier module, whatever. So I'll give you this ADC, ADS 1115. Or I can give you any ADC, analog devices. I can give you the ADC and DSC from analog devices which are 16-bit. Okay. So I can give you DSC also equivalent. So how to do it? Any idea? So this is the mid-sem question, suppose. So how to proceed? One step. Arundhati Naskar, you tell me, Arundhati.
Yes, sir.
Arundhati.
Yes, sir.
Are you there, Arundhati?
Yes, sir.
What is the difficulty here? Why it is not so simple, straightforward question? Arundhati,
Yes, sir.
you have a 16-bit ADC and this microcontroller is how many bits?
32.
भाई मेरे को बहुत शर्म आ रहा है तुमको सुन के, ठीक है? Because you are not at all attentive in the class. Is it a 32-bit microcontroller? Huh? Because this is AVR 328, that's why it is 32-bit. भाई IIT का कुछ लाज तो रखो, इतना मुश्किल से आए हो. How many bit microcontroller it is? 16. चलो. फिर next. देखो भाई, so I am not going to embarrass you. Please read it and come back. So I am not going to ask you any questions. But anyway, at least you are attentive. You are listening to me. you are coming up. Okay. So occurs.
Yes, sir.
Occurs बताओ.
It is an 8-bit microcontroller.
8-bit, very good. It's an 8-bit microcontroller. So interfacing 16-bit ADC is going to be a challenge, is it not?
Yes, sir. We would have to give it to 2 registers to handle it.
Yeah. So you have to, first of all, you have to interface where? In the ports.
Yes,
there are ports, port B, port C. So you all of you, please read about ports. I don't have time. It's very easy. Making input, output ports. So 2 ports, port B, port C, 8 bits. So both you will connect. Then when the AD conversion is complete, you have to use an interrupt so that one of the external interrupts, whenever the AD conversion is complete, you read the 16-bit number, right? So
yes,
keep on reading. Where will store these 16-bit numbers one after the other? चलो मैं दूसरा किसी को पूछता हूँ. हर्षल लक्ष्मण, खामकर हर्षल लक्ष्मण.
Yes, sir.
बताओ वो 16-bit नंबर कहाँ स्टोर करना है? एक करके फिल्टर करोगे या एक ग्रुप में फिल्टर होगा?
Sir, in the GPRs.
Registers. All right. So median filtering क्या है? Median filtering मतलब mid value, right? Yes. So how median filtering will get rid of spikes? If you continuously take 3 values, okay. Are you getting my point?
Yes, sir.
So the mid value to be replaced. The medium value will be replaced by the median.
Median of neighbors.
X1, X2, X3. There are 3 values.
Yes.
Suppose X2 is a spike. But if you take X1, X2, X3, the mid value will be X2. So it will be replaced by the mid value. So spike is gone. So read about median filter. You put 3-point median filter, 5-point median filter, it is there. So this 16-bit you store. Suppose it is a 3-point median filter. So 3 consecutive values you have to store. Then you have to do the spike removal, then send it to DAC. Again, DAC is maybe 16 bit. So, but suppose you have only one port. So how will you give 16 bit to the DAC? You have to do in 2 clock cycles by latching it properly. Think about it. All of you, please think about it. If you have any questions here, you ask. I am here to discuss. All right. So this could be a problem.
Sir, can't we use directly 2 ports for output as well?
There are 4 ports too, but if it is possible to use, no problem. But if there is another port is busy because you are using interrupt, so one port can possibly you cannot use. Therefore, you have to use only one port and you have to do 2 consecutive writes to have and latch it for 16 bit operation. That's what is the one which you have to do.
Sir, I have a question in this. So you said
Raise your hand and ask question. Don't otherwise I can. Subham, okay, please.
Yes, sir. So you said that we are using interrupts for ADC. Like our only job is to take this ADC and give out, do the medial filtering and give out to DAC. So why are we using interrupts? Like we can. Also...
So while if you don't use interrupt, then you have to wait till the conversion is complete. You give a start conversion and wait after the conversion is complete, bring it. So the conversion complete should be interrupt. So it will be use an interrupt to go to the subroutine to just get the ADC address and give another start of conversion.
Yes, sir. But here our only job is this. So no other thing.
No median filtering is there. So while the ADC is doing its job, you should do median filtering. Because you get samples fast, 3 samples you will get fast. So it will store in 3 registers. So then the computation will start. You find out the median, send it, then again read the ADC, wait for the ADC. So this waiting for the ADC will not be there if you use interrupt. That's what I'm saying.
Okay, yes, sir.
A good question. Any other question? Okay, so let's see some assembly language codes. What are the kind of assembly language codes I'm going to maybe I will ask, I don't know. So related to stack, maybe related to something. So let me just give you some examples. Because I'm not given you assignment, so you guys will be confused. So let me see what are the possible assembly language things you have to do. Assembly language assignments. Like factorial of a number, compute the factorial of a number, 8-bit number. So a factorial of 8-bit number can go out more than 16-bit. So you have to write an assembly code to compute the factorial. Then you can be maybe asked to do hand coding of certain instructions. You may be asked to also code back certain instructions. So these are the kind of assignments. Let me give you one. Let me figure out and give you one such instruction. So you may have to do something with the ports like stepper motor interface, DC motor control, all these circuits will be given to you, but you have to write codes. For example, suppose I ask you to make speed measurement of a DC motor by using an optical encoder. Suppose I give you. So how we are going to do this? So these are some of the things you can solve. For example, suppose I give you this. Find out the equivalent assembly code. Suppose I just type it here. Hand code this. This one you have to hand code. That means find out the equivalent code, assembly binary code or hexadecimal code. This could be one. So using the book, you can do that. Similarly, reverse code. That means disassemble. It is called disassemble. Suppose given these codes, like given these codes, you are asked to disassemble. Disassemble is find out the equivalent assembly language. What is that? So similar things. So suppose this one, let's work out LDI R2045. So can you just find out the equivalent assembly code? Let me just do it. I will ask questions. The first one. Find out the equivalent binary code of this. LDI R2045. Who can do that? Just do it and let me know. I've given you the assembly language manual. So go to the assembly language and find out. I will ask you after 5 minutes. Not 5 minutes, 3 minutes. Please open that assembly language manual. Guide which I have given already. So you have to go to that LDI instruction. Just search it, LDI. Hello. LDI instruction. Could you get it? I've given you already the manual, this LDI, just you search for that. So anybody who has done it, please tell me. If you look at your file section, it is there already. If you go to the file section, you can find out where it is. Embedded system, go to the files. Here assembly language guide is there. You can download that. If you are assembly language guide, you can download. Here assembly language download, which gives you all the instructions and the equivalent codes also.
Sir.
Yes.
So the format for this code will be like 1110, then 4 bits for the number which we are loading, then 4
Yes.
bits for the register,
Right.
and then again 4 bits for the
Excellent.
number we
Yes,
are loading.
That's it. Yes, got it. All right. That's it. So all of you, please do that. So in that assembly language,
Hello,
guide,
sir.
yes.
Sir, that first 4 bits will be MSB and last 4 bits will be LSB, right? For that K, means
Yeah.
the 45 we are loading.
Okay. Yes. Just 1 minute. So you can. LDI instruction is there in page number. Let me tell you. You can. LDI.
Sir, 115.
115, right? Yes, 115. Yeah, 115. So you can see opcode is 1110. That's it. So KK is the constant. You can see there. So D is this destination register. That is, and K is the constant here. That's all.
Yeah, sir, the first 4 K bits are for MSB and last 4 are for LSB, right?
Right.
And for DD we need to subtract 20, means 16 from that.
DDD is the destination R20. So 20 is the number here. RD is the destination register.
I'm getting E to ED.
Okay. E to ED. So can you assemble it in your thing and find out that whether it is E to ED or not? You assemble it. There is an assembler with you, na? So you can do that as well.
Yes.
All right, so guys, so I think we'll stop here. All the best for your exams. I want you guys to be little attentive because otherwise you will not learn this subject. This subject has so much potential. You can design your own product. There are a lot of, scope. You have to learn 32-bit controllers. I shall give you fantastic demos. Our products which are built, we have built lots of products here, and we are trying to commercialize it also. So I have been moving around many places, many countries, including United States. Okay, so we are trying to figure out, and this is the one thing which you can make you a very good entrepreneur with a very small investment. So there are many students who have been motivated and they have started their own thing and they are very successful. So I think you can also do that. So I hope that you will be more attentive in the class. Thank you very much. Bye-bye.